errors in measurements, and before that limitations of the dimensional formulas. Video start Janana Varun. The limitations of dimensions. Already you know the limitations. We have left something while solving the problems. Yes, and then we said that whenever we are having some function, we have to leave that functions, that and all are the limitations only. What are the limitations? Common limitations of dimensional formulas are, while doing the problems, what you observed? We have ignored which one? Coefficients, constants, trigonometric functions, all that logarithms, exponential functions, right? So whenever the formula came, otherwise whenever any physical quantity will come in terms of sine function or cos function, the best example is wave equations. Wave equations, otherwise SHM equations are coming in the form of trigonometric function only. Na? Y is equals to a sin omega t, obviously. There we are neglecting the sin omega t, means that is not correct thing. That is, there is some meaning there, that is defining the phase for us. What phase will indicate nothing but from where the particle has started to do the oscillations. So that is given by that phase angle only, sin omega t, whatever cos omega t is there. So in that we are neglecting that one, nothing but you will not get the proper answer for that. So that is also one of the limitation. We will neglect the numericals, that is one limitation. We will neglect the trigonometric functions, logarithm functions, and then exponential functions. That is also another limitation. Next, whenever you see, I said that whenever we have solved already, s is equals to ut plus 2gt square. Is that correct formula? Is that correct formula? It is not correct formula. Which is the correct formula here? Half at square is the proper formula. But even then we are saying that this is correct dimensionally. But what about this one? This is wrong. We cannot take that. We have to take half. We have to take plus. That will be the proper formula. So that is also one of the limitation. And also whenever you see work and then torque, same dimensions or different dimensions? Same dimensions. Why? Because this is force into displacement, this is the force into perpendicular displacement. So both are having the same dimension, that is how much? L square t power minus 2. This is also how much? L square t power minus 2 only. But the thing is here, work and then torque are completely different. There is no relation between the work and torque. Work, when work will come, nothing but by applying some force and making some displacement in the body, then work will come. Torque nothing but completely, that is a turning effect. Whenever any object is turning, at that time only it will have the torque. So completely both are irrelated to each other. But in dimensions, what we are saying, all are having the same dimensions. Yesterday I said some list only for you. So whichever I mentioned in that list are not same. Some of the physical quantities might be same. For example, if you see the work and then energy, both are same only. Why? Because work is equals to change in the energy only. Some of the physical quantities might be same, but the other are irrelated to each other, irrelevant to each other. At that time again we are saying that all are having the same dimensions. For example, if I have given L square t power minus 2, like this one dimensional formula I have given, you have to do the problem with that. So what you will assume? That is a dimensional formula of the work, even energy, for the torque, everything. So that you cannot get to know the proper concept from there, from the dimensions. So this one, whatever the physical quantities will have the different dimensional formulas, and then different physical quantities will have the same dimensional formulas. So we cannot say that this dimensional formula belongs to only one value. So this belongs to number of the physical quantities, so that we cannot get to know what is the reason for the problem. Clear? So those all are the limitations. One is whenever you come to the numerical values, for the numerical values there will be no dimensions. If we consider the numerical value, or if we not consider also, there is no problem in the dimensions. For example, if I say this one s is equals to half at square, if I consider the half at square, I will get the displacement as L only. If I not consider also, L only. So that is not the correct thing. Why? Because this is having some meaning here. It should be there. So that yesterday also I have said that energy stored in the capacitor only CV square. I have given, right, CV square, but actually what is the formula? Half CV square. If half is there or not there, it is not affecting anything in the dimensional formula. But in reality, half should be there. Why? Because other half energy will be wasted in the capacitor. Only half energy we will get. That we will discuss in the capacitor chapter. So here, that whatever the numerical value we are giving there, that will have some meaning. We should not neglect that. But in the case of dimensions, we have to neglect. Whatever the sine functions or cos functions we are getting, that should have a meaning, but we are neglecting even that also. Even one dimensional formula can be belongs to number of physical quantities. So we cannot get to know the proper reason for the problem. So that is also one of the limitation. Clear, right? So these and all the limitations of dimensional formulas. And also whenever you see for the basic dimensional formula, we can mention how many physical quantities, nothing but only 3 physical quantities. And after that we have extended that as an ampere and also temperature and all. But the basic dimensional formula will have only 3 quantities, 3 basic physical quantities. Though that is also one of the limitation only. Clear, right? Copy. Copy ಏನಿದೆ right ra. First one, first limitation. The numerical values in the physical quantities will affect the numerical values in the physical quantity will affect the quantity, but we will neglect in the dimensional formulas. Second limitation, assuming trigonometric, logarithmic, and exponential functions to be dimensionless, will affect the physical quantity Third limitation, all the physical quantities will not have unique dimensional formula. One dimensional formula can represent number of physical quantities. Next, significant figures. Very easy concept. All the significant figures, rounding off, and also mathematical operations with significant figures we will see now. So significant figures, what do you mean by significant figures? Significant, what do you mean by significant? Relevant values. All the any measurement if I have done, for example, if you see any decimal value, for example I have 12.100005, then what will write at the final value? 12.1 only. Why? Because 12.1 only significant, will assume like that, but in the rules it will be different. I am saying in real life, whatever in the mathematics we will do. So that significant nothing but the number of values, the number of digits which are relevant to the measurement. Any measurement, everything we will discuss from here onwards in measurements only. Any measurement we have done, we got so and so value, in that how many significant figures are there, to how much value you have to round off, what is the error will be there, what is the percentage error, what is the relative error, this and all will be there. And more than dimensions, this concept is very important. In this vernier calipers and then screw gauge also will come, basic problems will come from that, and we will discuss that also. So here everything we are discussing about the measurements only. So significant figures nothing but the relevant, the proper digits in the value whatever we got, those are known as what? Significant figures. The relevant digits only you have to take. That might be how many ever. In that, how many are relevant, how many are irrelevant, you have to find out by the number of rules. So first rules of a significant figure is all the non-zero values are significant. All are significant here. For example, if I say some number 2, 3, 5, 6 like this, how many significant figures are there? Nothing but all are significant only. So that what I can say here, 4 are the significant figures. Okay. Next rule is the zeros between non-zero digits. Non-zero digits are significant. So that here, for example, if I say the same number 2, 3, 0, 0, 5, 6, how many significants are there? 6 significant figures are there here. Why? Because I said zeros between the non-zero values. These two zeros are also significant. Why? Because they are there in between the 3 and 5. Clear, right? So the zeros which are there in between the significant figures, in between the non-zero values are also significant. So how many significant figures here? 6 significant figures. For example, if I say decimal values, whenever I got the decimal value, that value is less than 1. Whatever the measurement, I have measured something from the, for example, balance I have measured, I am just measuring 2 grams like that. So at that time, whenever the value is less than 1, at that time, the zeros left of non-zero values are not significant. So understand by the example. I said less than 1, nothing but I will take it as 0.0023. How many number of significant figures are there here? Only 2. Whenever you got the decimal also, but the value is how much here? Less than 1. At that time, all the zeros which is left side of the first non-zero value. Left side of the first non-zero values, these 3 are not significant. So which are significant? Only 2, 3 is significant. For example, if I say 0.002003, how many significant figures are there? 4 are there by the second rule. Between the non-zero values, zeros are significant only. So only these 4 are significant. That is the third rule. Whenever you say the fourth rule, the terminal zeros are non-significant. Non-significant means, for example, if I have 11000, how many significant figures are there here? 2. Why? Because everything is terminating zeros here. Those are terminating the value here. So that only how many significant figures are there? Nothing but 2 significant figures. So that I can write it as directly 2. Clear? Now, whenever I got the same terminating values with a decimal also, for example, 0.00200300. How many significant figures are there? 4. Again, why? Because these terminating values also non-significant. So that how many are there here? 4 are there. Clear, right? So, and also powers of 10. Whenever you are raising some value by the powers of 10, what we can call it as nothing but order of magnitude. You might be solved in some of the problems. Some of the people ask me the doubts also. You will get some value into 10 power. That 10 power value only they are asking. So order of magnitude, that also we will discuss. So those are also non-significant figures. Nothing but the powers of 10. Powers of 10s cannot affect number of significant figures. For example, I have 2.3 into 10 power 5. How many significant figures? Only 2 significant figures. One is 2, another is 3. Only 2 significant figures. In the same value, I can even write it as what? 2.300 into 10 power 3. How many significant figures again? 2 only. Why? Because these 2 are which zeros? Terminal zeros, terminating zeros. And then these are non-significant. So that how many are there? Only 2 are there. And also for this extension only next one will come, changing in the order of unit. Changing in the order of units does not affect the number of significant figures. So here, for example, if I say my value is 101 centimeters. 101 centimeters is there. So how many significant figures are there here? 3 significant figures. So 3 significant figures. Now this one I can even write in millimeters also. What I can write? 1010 millimeters. Why? Because 10 millimeters is equals to how much? 1 centimeter. Now how many significant figures are there? 3 only. Why? Because this is a terminating 0. Correct? Only 3 significant figures are there. Otherwise, if I say I have in measurement 1.2 kg. 1.2 kg. Nothing but how many significant figures here? 2 significant figures. I can write the same thing as 1200 grams. How many significant figures are there again? 2 only. Why? Because the remaining are which zeros? Terminating 0. Otherwise, I can write the same number as 1.2 into 10 power 3. Again, how many? 2 only. See, if you see 10 powers, otherwise changing in the units does not affect the number of significant figures. Clear? So, the first rule is whenever you see all the non-zero values, all the non-zero digits are significant. So, that might be anything. Whenever you take any number, that might be any whichever the number you have taken, that might be very big also, very small also. All the non-zero values are significant figures only. So, all the non-zeros are significant. The zeros are involving in between the non-zero values. Zeros involving in between the non-zero values are also counted as which figure? That is significant figures only. So, that 2, 3, 0, 0, 5, 6. How much? That is 6 significant figures are there. Next, whenever you see, whenever the value is about the decimal value and which is less than 1, at that time what happens? Nothing but the zeros in front of the non-zero values all are non-significant only. So, zeros in front of the non-zero significant figure is how much here? 2. Zeros in front of the non-zero value is 2 here. In front of that how many zeros are there? 3. How much ever that might be. But all are non-significant. For example, if I say a value like this, how many significant figures are there? 6. As per the second rule, what we can say? The zeros in between the non-zero values only. That might be having the decimal point, otherwise not. But it should be, you have to follow the second rule that between the non-zero values, all the zeros are significant here. So that 1, 000 and then 5, 3. In that how many significant figures are there? Nothing but 6. Now you tell me. 0, 1, 2, 3, 0. How many significant figures? 3 significant figures. By the rule 3, all the zeros between the before the non-zero is not significant. And also this one is what? Terminating zeros are also non-significant figures. So how many are there? Only 3 figures are there. Clear? So that is about the third rule. Next, fourth is terminating zeros or terminal zeros are non-significant figures. So anything, you might be having doubt that this one is 11,000, you are saying that 11 only significant. I am not saying about that significant figures will give you the entire value. It will not give you the entire value, proper value. You are just finding that which are significant, which are non-significant, which are necessary, which are not necessary. And by the significant figures, you are not giving the final result here. So you are just finding in that which I can take, which I cannot take. That's it. For the next any experiment. So here 11,000 nothing but, for example, if I say any 1 millimeter normal centimeter scale I have taken, small centimeter scale, how many centimeters will be there in that? 15 centimeters will be there. So that here what I am writing nothing but, so my value is, I got exactly 1.1. Instead of writing 1.1, I will just write 1.10004 zeros. Then what is the use of that? Understand, right? So you are just finding that which are necessary, which are not necessary. That's it. This is not about the final value. I am not saying that significant figures will give you the final result. That is not the proper thing. So here 11000, in that these 3 zeros are terminating zeros, so that those are non-significant. In the same way, powers of 10 also, that will also not affect the significant figures here. And also changing in the units also does not affect the significant figures. If you are converting 1 kilometer, nothing but how many significant figures are there? 1 km, only one significant figure. 1000 meters if I say, only one again. Why? Because 3 zeros are not necessary there. I have measured already in kilometers. If I say in meters, otherwise if I say in millimeters also, that will not affect the distance. Distance is distance only. If I measure with the meter scale, otherwise if I measure with the centimeter scale also, distance is same only. I am not changing the distance here. That is not affecting the value here. So I said in the dimensions also the same thing. Whenever you are changing the units of any proper physical quantity, it will not affect the quantity. So only n into u is always is equals to constant. So only what will get? N1 u1 is equals to n2 u2 will get. In the same way, here also whenever you are changing the units from smaller to bigger, otherwise bigger to smaller, it will not affect the number of significant figures. So whatever there before and the same values will be there in the after also. Clear? So this is about the rules of the significant figures. I will give the examples. First of all, write the rules. First rule, significant figures. First rule, all the non-zero digits are significant. All the non-zero digits are significant. Write that example. 2, 3, 5, 6. Underline the number of significant figures, if possible with other pen. With other color pen, you just underline that. Next, second rule, zeros between non-zero digits are significant. Zeros between non-zero digits are significant. Like that second example, 2, 3, 0, 0, 5, 6. Underline all. Six figures. Third one, when the value is decimal, and which is less than 1, comma, the zeros preceding non-zero digits, the zeros preceding first non-zero digit are not significant. First non-zero digit are not significant. Write that example, 0.0023. Underline 2, 3. Only two significant figures are there. Write all the examples. Whatever I have written there, 4 examples I have written. Write all of them. Next, fourth rule, terminating zeros of any number are not significant. Like that 11,000, only two significant figures. Write the next example also. Compulsorily you should underline the significant figures. Next one, the order of magnitude or powers of 10 cannot affect the number of significant figures. Copy that examples. Next one, changing in the order of units of the same quantity, changing in the order of units of the same quantity does not affect number of significant figures. Number of significant figures. Hello? Finished, huh? Had a problem? Find the number of significant figures in the following values. First one, 1, 2, 3, 7, 6. 1, 2, 3, 7, 6. How many figures? 5. 6024.7. 6024.7. Again how many? 5. What about the 0 in between? Significant. That is why, because it is there in between the non-zero values. Next one is 0.071. 2 significant figures. Which are 2? Which are those? 7 and 1. Next one is 410. 410. How many significant figures? 2. Which are those? 4 and 1. 2.40. 2.40. How many significant figures there? 2 are there. Then next one is 1.6 into 10 power 10. How many significant figures? Why? Because 10 power 10 is not affecting any values here. Clear? Huh? Then the next problem. In that only you write the numbers. 227.2 grams. 227.2 grams. How many significant figures? 4 are there. All are significant only. Why? Because all are non-zero values there. Then 3600 grams. 3600. Kelo pa, first number kelo. 3600 grams. How many are there? 2. Those are what? 3 and 6. ಏನು ಬ್ರೇಕ್ಫಾಸ್ಟ್ ಇವತ್ತು ಮನೆಯಲ್ಲಿ? ಏನ ಐಶ್ವರ್ಯ? ಪುಳಿಯೋಗರೆನಾ? ದೋಸೆನಾ? ತಿನ್ಬೇಡ ದೋಸೆ ಯಾವಾಗಲೂ. ನೆಕ್ಸ್ಟ್ ನಂಬರ್ ಈಸ್ 0.00602. 0.00602. In that, which are significant? 602 are significant. Then next one is 2.50 into 10 power 10. How many are there? 2. That is about the basic significant figures. Then after that we will see the round off. Already you know this clearly. How to round off the values. I will feel everything you know, but you don't know. What is the round off rules? What do you have to do? I will think that, okay. Round off with a radius of so and so. Round off with a radius of 1 meter. And then illa andre nidde ಮಾಡಿ round off ಮಾಡಿ ಈ ತರ ಸೆಮಿ ಸರ್ಕಲ್ ಆಗುತ್ತೆ ಈ ತರ. ಯಾವ ವಾ ಏನು ಐಡಿಯಾ, ವಾಟ್ ಎ ಐಡಿಯಾ ಸರ್ಜಿ. Round off rules. Whenever, yes, we have round off 1 also. OMR sheet nage round off ಮಾಡಬೇಕು with pencil. ಇಲ್ಲ ಅಂದರೆ ಒಂದು ಪಿನ್ನಿಸ್ ತೊಗೊಂಡು ರೌಂಡ್ ಆಫ್ ಮಾಡಬೇಕು, ಅವಾಗ ಬರುತ್ತೆ ಮಾರ್ಕ್ಸು. Round off to 3 significant figures. Round off to 3 significant figures I said. How much? 1.23 only. Why? Because you have to observe the number which you have to cut off. Last number should be cut off. So if I say you have to round off to 2 significant figures, nothing but first you have to round off to 3, then you have to come to 2 again. Clear? First only at a time we can remove only one digit there. So you have to decide first of all cut off digit here. 4 is a cut off digit, and you have to observe that 4. If the 4 is less than 5, then you have to leave as it is. There is no change in the number. Whenever you want to drop the number which is greater than 5, at that time what you have to do? Nothing but you have to do +1 for the preceding number, preceding digit. Understand the concept, right? Last number is whichever you want to cut off, that number is less than 5, nothing but you have to just drop that, drop and then leave, drop and then leave the number. Then whenever you see the last number is greater than the 5, at that time what you have to do? You have to raise the before one by 1. If I say 1.238, how much you will get? 1.24 you will get. Why? Because you have to observe the cut off digit here, that is 8, and just observe that 8 is greater than 5. Whenever it is greater than 5, at that time what I said, you have to do +1 for which number? Preceding digit. So preceding digit is 3 here, 1.2 as it is. For the 8 preceding digit is 3, for that you have to do +1, nothing but what will get here? 1.24. Clear? Then for example, if I say we are having the number as 1.23565, round off to 5 significant figures.
1, 2, 3, 5, 6.
6 ಬರುತ್ತೆ. Let me take another number, 1.2355.
1, 2, 3, 6.
Now I said to round off for 3 significant figures. 3 ಅಲ್ಲ 4. 1.23 6 ಯಾಕೆ 5 ಇದಲ್ಲ, ಬಿಡಬಹುದಲ್ಲ? Yes, that is the rule. Next rule. So whenever you want to round off for the any number, and then you want to drop the last number which is exactly 5. Here we have discussed this is less than 5 and then greater than 5. Whenever it is exactly 5, at that time what to do? Nothing but you have to observe the just before number. You have to observe the just before number, so that just before number is even number. Even number, at that time you should drop this, and then you have to leave the number as it is, 1.2356. Whenever you see the odd number before the 5, this is also 5 only, 5 is odd number obviously. Whenever you see this one, at that time it is looking like odd, so that what you have to do? You have to just add 1. Okay, even is even only, odd is odd obviously, so that you want to make it even, nothing but what you have to do? You have to do some change, so that what you have to do here? +1. Then mimicry ಕೊಡ್ತಾ ಇದೀವಿ 1.236. Clear? You understand, right? So in rounding up there are four rules mainly. One is you have to observe main dropping digit which you have to drop. In the dropping digit is less than 5, at that time what you have to do? You just drop it and then leave the number as it is. Whenever which is more than 5, at that time what you have to do? Nothing but you have to look at the preceding digit and then make it as +1. And also whenever you see the last number is 5 only, at that time again you have to take care of 2 things. One is preceding digit is even, drop it and then leave as it is. Preceding digit is odd, at that time you just add by +1. Clear? All the rules. For example, if I said this number you have to round off to only 2 significant figures. Round off to 2 significant figures only. First of all you have to come from there, last. You have to drop each and every number at every time whenever you are calculating, and then you have to get the answer. So whenever you come to the 5, at that time we can drop the 5 because before what is there? 6 is there. Whenever you come to the 6 here, 6 is greater than 5, right? Greater than 5, nothing but what you have to do? What will you get here? 6 will get here. Plus 1 you have to do. Why? Because this 6 is greater than 5. Then this here how much it is coming as? 6 it is coming. Then this is 6. Then it is greater than 5. Then what you have to do? Before number 4. Then you have to come to the 4. 4 is less than 5. Then what I can do? I can drop it. Then how much is remaining? Only 1.2 is remaining. You are able to follow that? See that. I will give another example. Let me say, if I say 5.203185. Round off to only two significant figures. How much it is? 5.2. See that. First of all, 5 is there here. 5 means before number is which one? Even number. Before number is even, nothing but what you have to do? You have to drop it and then leave the number as it is. So that what you have written here, 5.20318. I dropped 5. Then next come to the next number. In that 8 should be dropped here. 8 is greater than 5. Greater than 5, nothing but what I have to do? Before number you have to add by 1. So that now we can drop this one. So what is our next number is? 2032. Why? Because I have added 1 plus 1 here. Then again you have to observe the number to be dropped. This one is 2, which is 2 is less than 5. So that we can drop it and then leave the number as it is here, 5.203. Next one is, whenever you observe the last number, this is also what? Less than 5. Less than 5, nothing but what we can do? We can drop it and then leave it as it is. So that what is coming here? 5.20. Then 0 also less than 5 only. We can drop the 0 as it is. Then what is our final answer is? 5.2. Clear? Then next one is, next example is, for example, if I say 5.205. I said even, I said odd. What about the 0? ಎಷ್ಟು digits ಅಂತ ಇದ್ರಾ? 2 digits ಗೆ. How much it is? 5.2 only. See that whenever it is 5, at that time before 0 is there means you just drop it and then leave as it is. Okay, there is no change in that. And then whenever number of significant figures I am saying, for that you have to round off. If I say two significant figures here, 5.205, last I got 5, but for 5 I said two rules, one is even, another is odd, but this is 0 here. For 0 also you just consider it as a even only and then close it here. Then 5.20 is there, 0 again round off, then what will you get here? 5.2 only. Clear? That is about the round off rules. First one is, one rule is, for any rule you have to observe the last number, last digit. If that is less than 5, drop that and then keep the remaining number as it is. Whenever it is greater than 5, at that time what you have to do? Just observe the preceding number and then add 1, then drop that, then you will get the remaining value. Whenever we get the last digit as 5, at that time you have to observe the preceding values there. Preceding digit is even means drop that 5 and then write as it is. Preceding digit is odd means then what you have to do? You have to add by how much again? 1 and then you have to drop the 5. If preceding digit is 0 means you can consider that as also even only and then you can drop it and then leave the number as it is. And then rounding off nothing but you should round off to particular number of significant figures only. Round off nothing but I can drop it one time and then I can leave the number. But you have to ask that how many numbers we have to round off for. Clear? Right, that rounding off rules. Everybody understood, right? If you don't understand this also means you have to sit in the second class or third class. Rounding of rules. Rounding of rules. First rule. Observe the last digit. Observe the last digit in the given measurement. Observe the last digit in the given measurement. If it is less than 5, if it is less than 5, just drop that digit, just drop that digit, comma. If it is greater than 5, if it is greater than 5, if it is greater than 5, then drop the digit and add the preceding digit by 1, add the preceding digit by 1. At these two examples, 1.234, 1.238, 1.234, 1.238, round off for 3 significant figures, round off for 3 significant figures. Next one, next rule. If the number to be dropped, is exactly 5, the number to be dropped is exactly 5, then observe preceding digit, comma, if it is even, then drop the 5 and take the value as it is, comma, if the preceding digit is odd, then drop 5 and add the preceding digit by 1, Take the examples. These 2 examples you write first of all. Above 2 examples you write. Next, right? If the number to be dropped, is 5, and its preceding digit is 0, then apply even digit rule. Write the example. 5.205, 5.205, write the rounding value of as 5.2. The next line you write. If the value to be rounded off is having more number of digits, is having more number of digits, and to round off for less digits, to round off for less digits, we have to follow the procedure for number of times. You have to follow the procedure for number of times, and each time only one number should be dropped. Only one number should be dropped. Copy this example. Copy this one. Next, order of magnitude. Order of magnitude. Order of magnitude. For any measurement, if its value raised by 10, the power of 10 is known as order of magnitude of that value. Order of magnitude of that value. Like that, measurement is equals to A into 10 power B, where B is known as order of magnitude. B is known as order of magnitude. If I say the electron value, electron charge, 1.6 into 10 power minus 19. So 19 coulombs obviously. So here, which is the order of magnitude of the charge? Minus 19 is the order of magnitude of the charge. Clear? Next, mathematical operations with significant figures. Mathematical operations with significant figures. Very easy, but you should remember the rules properly. Very, very easy. So first one is addition and subtraction. For both, same rule will be there. Addition or subtraction. In addition and subtraction, first of all, listen the rule properly. First of all, you have to observe the numbers. Whenever you observe the number, after the decimal point, how many significant figures are there, you have to remember. So after the decimal number, I have 2 significant figures in one number, 3 significant figures in the other number. In that, you have to identify the least number of significant number. Then you have to take that as it is. The remaining number you have to add should have how many significant? Nothing but only n plus 1 value should be there. For example, I have taken a number as 1.23, another number as 3.5648. I have two values like this, and then I have to add them in the form of significant figures. Then what you have to do? Nothing but first of all, you have to observe the decimal point. After the decimal point, how many significant figures are there, you have to take. So after the decimal point, for this, how many significant figures are there? 2. After the decimal point, how many are there here? 4 are there. I am saying only after. I am not talking about the total value. I am saying only after the decimal value, after the decimal point. After the decimal point, here I have 2 significant figures, here 4 we are having. If I take one more number, for example 1.00832, in this how many are there? 5 significant figures are there. Why 3?
6 ma'am.
After the decimal point I am saying. If you are taking all the significant figures, means you will get the wrong answer. I am saying about here, for example, I may have 51 point this one. So how many are there again? 5 significant figures only. You should consider only after the decimal point. So here how many are there? Nothing but only 5 are there. 5 significant figures are there. So here 5, here 4, and then here 2. You have to take the least number of significant figure value. What is that? 2 here. So take it as n. N is equals to how much? 2 here. Then after that, while adding, what you have to do? Nothing but you have to take care of the other numbers. They should have either n numbers, otherwise n plus 1 digits. So here this is n is 2, nothing but this one should have how many? Either 2 or 3. You have to, if it is not having nothing but you have to round off that. It is having how many significant figures? 5. But how many should be there? 2 or 3 should be there. Minimum is 3. Okay. Above 3 you should not have. So that here what I can write, nothing but this one you have to round off to how much? 3 point. Here 8, right? 8 nothing but this will be how much? 5. 5 before 6 nothing but what will get? Even if we can have n plus 1 also, right? So that what I can write? 5, 6, 5 I can write directly. Here 2 are there, here 3 are there. There is no problem. Even you can round off for the 2 also. There is no problem in that. Next one is 51 point. Here 5 are there. 2 nothing but I can drop it. Next case what we can do here? 3. Again I can drop it. So how much is there here? 008. Now again I have 3 here. Either n or n plus 1. Now add them. Mathematically you add and then get the answer. In the answer what you should have? Nothing but again you should have the least number of significant figures only. Okay. Whenever you add them again, in that again you should get the least number of significant figures. Clear, right? Yes, write the rules first of all. Later on you can add. Addition or subtraction. First step, observe the values to be added. Observe the values to be added. Observe the values to be added and count the significant figures after the decimal point. After the decimal point. Next step, second one, select the least number of significant figures as n and the other numbers to be added should have either n or n plus 1 significant figures after the decimal point. N or n plus 1 significant figures after the decimal point. Comma, to get that we have to round off the digits. The next step, perform the addition or subtraction. and round out the final answer to have least number of significant figures among the given values. We'll continue after the lunch. Pause that. I'll only take after the lunch also.